Okay, so welcome to this presentation. First of all, I would like to say that at Mobenga we have been working with Docker for quite some time now, but we just got started with Kubernetes. So what I'm presenting today is the results of our investigation on how we will move forward, probably. So,
I'm sorry.
yeah, sure.
Could you just switch back to one slide? Oh, I think we started it.
We started it, yeah.
I have started. Oh.
You want to restart it now?
No, I just put it up. Sorry.
Okay, I am Johan Frick. I'm a system architect at PBS, Playtech BGT Sports. And as Gabe said, we are always looking for talented people. At PBS, we create sportsbook betting applications for the web. And in the Malmö office, we are responsible for the front-end parts, the web clients. We're always connected to some betting company to get data from their API. But we need some services on our side as well, because the data coming from the betting company is not always optimal. So we need a content service to structure the data to be optimal for the web client. We need one more service in the front-end stack, and that's endpoint service. And this is just connecting to the clients over HTTP and WebSockets for sending data. We need some glue in between the content service and the endpoint service. And we have two off-the-shelf products. We have the Redis, which is message bus and pub/sub service. We're using that for notifying endpoint services of new content. And we're using MongoDB, an OSQL database for caching content. Okay, so that's our front-end stack. And we want to deploy this on Kubernetes. To be able to do that, we need to have Docker images. So that's where we're going to start. Our services are created in Java, and they are using the Spring-Boot technology from Spring Framework. Spring-Boot is focused on microservices, and that's what we're going to focus on moving forward with our architecture as well. So let's see how we build Docker images to start with. Can you see the text? Not sure if I should point there or here. I'll pick this one. So we need to have a small Docker file, and that's needed to create a Docker image. You usually base your Docker image on some other image. So we base our on OpenJDK, the Java image. We use Java 8. We only need the Java runtime environment, and we use the Alpine suffix, which is a minimal Linux distribution, very popular with Docker images. Now we copy our jar file over to the root folder of this image, and we set a default command to run our endpoint server. So there we're done with the configuration on how to build a Docker image. Now we can build it. We do docker build, current directory holding the Docker file, and give it a name. And that's the output from it, and we have our Docker image. We will do similarly for the content server. So we're ready to run our front-end stack. Docker run -p 8080:8080 endpoint server, and this part here is to expose the internal port 8080 from the endpoint server to the local machine, the host machine. In my case, my computer here, so I can access localhost 8080 to get to the web UI of the endpoint server. We should run the content server, of course, and we should also run Redis and Mongo. We expose the ports from those as well. So this is one way of running a Docker locally, but we could move this configuration to a configuration file, and that's where we're going to use the Docker Compose concept from Docker. So this is a Docker Compose file. The first line is the syntax of the Docker Compose file, the version of it. And here we list our services again, and we have Mongo, service name, the Docker image, and the port we expose. We see here at the endpoint server, it's a bit longer image name, and that's because we have it hosted on our private Docker registry. So dockermobenga.com is our private registry. We expose the ports like we did on the previous slide, and we can set some environment variables for the endpoint server. So Redis here Docker will resolve that one to the Redis service so they can communicate with each other. So that's all we need to run our stack locally. So it's time for a demo. We are in a folder where we have the Docker Compose file. So now we simply run the Docker Compose command, start it up, and in detach mode, so we get back to our terminal. Starting up there, we could do Docker Compose PS to list the services. I'm gonna zoom out a bit. Let's do a watch on that one. Okay, so there are actually a few more services here. We have our content service. We have our, endpoint service. We also added the Elastic stack, the ELK stack, and that's for gathering logs from many services, and that's very convenient. Let's say we want to scale up our endpoint server to have 100 endpoint servers because we have a lot of users. We will get all the logs from all the services into our ELK stack, and we can view and search the logs from web UI. We have a few other services here. We have the Mongo UI. That's just for viewing the MongoDB data in the web browser. Cloud Panel I will show soon. And we have two different jobs here. We have Mongo Prepare. And this one will dump some data into the MongoDB because from this place we don't have access to the betting company API. There's also Elasticsearch configurer to set up an index for the logs we are sending to it. So all services are up except the jobs because they are just going to run once and then exit with a successful 0. We see the ports on the right side. Here. So now we can open up the Cloud Panel. So this Cloud Panel is just a small app we're using locally when we develop to list some selected services and some web interfaces in our stack. For convenience, for watching the status of the service and to have direct links to our web interfaces. So let's see what's running. All right, so we have a betting application here. This is the one we have showed at the betting fair in, was it February, I think? The ICE fair, as an example. We have MongoDB browser. This is not something we built. This is directly from the Docker Hub. And we have the Kibana interface from the ELK stack. So here we see, here we can have all the logs from all the services. We can filter on a level, for instance, so we remove the bug. We can select which app we want to view logs for. Maybe we only want to find items on event-ended update job. So we search for that one. And we should get the matches. Did I search?
Can we ask questions?
I prefer after, if it's not something obviously wrong. Yes? Okay, so that's it. We have it locally, but that's not why we're here, right? So we have our local Docker stack. We have proven that our Docker images are working locally. So one step closer to deploying in Kubernetes. Let's go back to the presentation. So to deploy to Kubernetes, we of course need a Kubernetes cluster to deploy to. And why not use Google Cloud Platform? It's Google I/O Extended today. So what you're going to do is you go to try it for free. You will get 12 months free trial with, I think it's $300 worth of computer power for free. So just go there, register, and you can set up your project. I created one called Kubernetes-JF. Next step is to download the Cloud SDK, the Google Cloud SDK, and install it. Now we're ready to work with our G-Cloud, Google Cloud. You should do G-Cloud init, and you will get directed to a web page where you will log in with your Google account, and then you're connected. You will select the project you have created, and now we're ready to set up our Kubernetes cluster. The command is gcloud container clusters create K0. K0 can be whatever name you choose, and then we have a Kubernetes cluster in the cloud. Next step, because we want to control this Kubernetes cluster locally, we do gcloud container clusters get credentials K0. And now we have credentials stored locally for the Kubernetes cluster. And then we can install the kubectl command. And that's the Kubernetes tool, not something Google Cloud specific. You can download it from Kubernetes website, or you can install it using gcloud components install kubectl. And then we're ready to run the kubectl get all to list all services and deployments and so on. But of course, we will not get anything back except an empty list because we haven't yet deployed anything. So there's one more step before we can actually deploy. We created some local images that are not available globally. There are some images, there are a lot of images available for everyone on hub.docker.com. Any service technology you can think of that's available globally is also available as a Docker image. So here we have the most popular ones. We have Nginx on top, Redis, Ubuntu, Mongo, and so on and so on. But that's for official global images. We have our own built, so we need to push those images to Google Cloud. Let's see what images I have locally. Is that too small? So we have these images locally because we started up the stack locally. Some of them are global, so we don't have to push these images, but all the ones that are prefixed with docker.mobenga.com should be sent to the Google Cloud. So we use the docker tag command. We start with the endpoint server, and then we give it the name of the repository on the Google Cloud. And I am hosting my project on the European Google Cloud, so that's the host name for that one. And then I add my project name, and then whatever name I want to set for the service. Docker images, and there we see we have a tag for that one. Now we use the gcloud command to send it to Google Cloud, push. And it will upload it, and fortunately I have prepared this. Seems like it's taking some time. So I have done all this for all those images I had locally, so we can list the images available. So I query the repository for my project. And I can see that there are my images in the cloud. So now we have all our images available. So let's talk a bit more about Kubernetes. I want to go through some concepts in Kubernetes. First of all, we have pods. So a pod can be seen as a logical application. A pod can have one or more containers, and it can also have volumes. It has one shared namespace in the pod and one IP per pod. So in this example here, we have the Nginx container based on the Nginx Docker image, and we have our own app and 2 volumes connected to it. There's an IP assigned to it, and everything inside the pod can can be seen as one machine. It can communicate with each other through localhost, for instance. The other concept I want to talk about is services. So services is how pods communicate with each other. So it's persistent endpoints for pods. Here we have one service that's exposing the hello pod. This hello pod is actually replicated out to 3 nodes. A service always has an internal IP available for everything in the cluster. And if you configure it, you will have an external IP as well for that service, so you can access it outside of the cluster from a web browser, for instance. So the communication between pods, we have an image here showing that. We have our Redis pod. It's exposed through a service we have named PubSub service. On another node, we have a pod called endpoint service, and this one will invoke the service with the subscribe command. This one will be forwarded to the Redis pod, where it will set up, register the subscription. Then we have a content service in a pod. It will publish to the PubSub service, and that publish will be forwarded to the pod, and then it will look at its client and forward the message to the endpoint service. So that's how you communicate between pods in a Kubernetes cluster, through services. We're getting closer to actually deploying. Let's have a look at this folder again. So we had our Docker Compose YML file. This one has to be converted to Kubernetes configuration files for deployment. And I have those files in cube files. Let's see what we have there. Let's have a look at one of them to begin, Redis. So here's how you configure deployment for Redis. First of all, deployment kind. This one will result in the pod for the Redis. Give it a name. We have a label, app Redis, and here we have containers where we give it a name for the container and where we connect to our Docker image. Then we expose the internal port 6379. After that, we have a service, the Redis service. This name doesn't have to be the same name as the deployment. We expose the same port, the target port 6379, we expose out from the service as the same port again. Very important, in the bottom here we have selector app Redis. This is actually what connects a service to a pod. So it has to be the same one as this label here. It doesn't matter if they are in the same file or whatever. It's the selector that determines which pod is connected to which service. So that's all we need for the Redis. Let's have a quick look at Mongo UI. It's very similar except for the last line. Here we have type load balancer, and this means that we will get an external IP for this one because we want to go into from any machine and look at the MongoDB data. What else? We can go into something that has a bit more configuration. Endpoint server, there's more configuration there. First one that's quite interesting is the replicas. So you only need to add one line if you want to scale up your servers. Replicas 3, now I will get 3 endpoint servers exposed to the users. We have a volume mount here, and this is where we can link in external files. And with Kubernetes, that is done through something called config map. So we have a config map available named sportsbook config. In that map, there's a key logback XML with the content of a logback XML file. This one will be available, and then in the container, if we go up in our endpoint server container, we will mount the config volume to a log config path. Finally, we have for environment variables for this endpoint server, we set logging config to /log config /logback XML. And now the logback XML is connected to our endpoint server. There's some more configuration here. We have some Spring configuration, Java memory settings, and so on. What's important as well here is the Redis host. So here we have the value Redis, and this is actually has to be the same name as the service, the Redis service that we set before. And then Kubernetes will resolve that. That's it. of course, we have a service here as well with a load balancer because we want to access the sportsbook from a web browser. Quick look at the Elk stack. It's a longer configuration. I just decided to bunch them all together in one file. These are not our own services, so I just added them in one file with preferred configuration and with services for Logstash and Kibana and Elasticsearch as well. Kibana, of course, with a load balancer. Finally, we have some jobs. The configuration looks the same as the deployments, except for it's a kind job. So Kubernetes does not like deployments that will stop after a while. It wants to have continuous deployments running. So do a job if you want to do a one-time, do a kind job if you want to do a runtime job. And there's no service here because this one should not be exposed to anything else. It should just run and then exit. I think that's all of them. So we needed a configuration map, so let's create that one. We used the kubectl, kubectl command. Kubectl create config map, and from the deployment configuration we named it sportsbook config from file. I'm in the wrong folder. So that's the command you run. I got an error because I have prepared this. So yeah, the configuration map is created. So I just wanted to show how you create it. So if we look at the config folder, there are the 3 configuration files needed for. One is for Cloud Panel to define which services to show in the Cloud Panel web UI, logback XML for configuring Java logging, and Logstash configuration for configuring Logstash, how it should communicate with Elasticsearch. So now we have a configuration map of that. Finally, we're ready to start it. kubectl apply, recursive because it's a lot of files, not just one, -f, and then kube files. That's the command, and I prepared that one as well. So when you run it, you will get outputs, deployment created, service created, and we have a replication controller. I will show that later, and the jobs as well. So it's all running. Now we can see what we have. Here are all the pods we have. One for each type of pod, except for endpoint server. We wanted 3 of those. And we have our services. All the services, everyone has an internal cluster IP, and some of them has an external IP as well. The exposed ports and how long they have been running. So let's look at the Cloud Panel. There we go. We're up in Kubernetes. And the sportsbook is available, so you can go to this address and start betting. No, it doesn't actually work. Betting is disabled, but you can look at some odds and stuff, and it's old dumped data, but it's available for everyone, this sportsbook. And we can also look at the Mongo browser and Kibana. How much more time do we have? Do we have time for a bonus feature? Yeah. So let's look at MongoDB. We have MongoDB, we have version 3.2, and we have decided that we want a newer version of it. We want to have 3.4. So then Kubernetes has something called a rolling update. This one will update the Mongo deployment, and we select simply select a new image available in the Docker Hub. Let's see, There you see it better maybe. Kube control rolling update Mongo, and we select a newer version of the image. Actually, let's have a watcher on watch kubectl get pods.
You can do kubectl minus v.
Ah, nice. Is it better? Thanks. There?
At the end, I guess.
Yeah,
Look at it.
of course.
And just let it go. It will show every update.
It's not better indented. Okay, so let's run the command now. And there we see that Mongo will scale up and add some more pods. I don't think that the watch command is actually better. So now we have 2 Mongo pods running. I didn't add an update period, so it will actually take 1 minute for it to scale up one of them and scale down the other. So we will have to wait 1 minute. So it's still 3.2. Oh, I cancel it. No. 56 seconds. Okay, we have a counter here. Very close. Let's see now. Whoa. Not sure if I cancel it up here. Okay, let's wait for that one. I think that's about it. Thank you.